Welcome to qnawire.
All right, in question 87, we're looking at Fe2O3. Um, it says that that's one of the products when iron corrodes, is that rust. But other corrosion products include an FeOOH, which is iron oxyhydroxide, and magnetite, which is Fe3O4. And then question A says, what is the oxidation number for Fe in this guy here first, in the oxyhydroxide, iron oxyhydroxide, assuming the oxygen's oxidation number is -2. All right, so if oxygen is -2 here, so I'm going to rewrite this. So we have FeOOH, and this is -2, and this is -2, and hydrogen is not by itself, so it's not 0, and it's not a hydride here, so it must be +1. So we can solve for the oxidation number in iron. I'm going to call it X, plus there's a -2 for this oxygen, a -2 for that oxygen, and a +1. And that's overall, this doesn't have any charge, so that's going to equal 0. So I have X, so that's -4 plus 1 is -3 equals 0. So X equals +3. So my oxidation number on iron in that case is +3. In part B, it says the oxidation number for Fe and magnetite was controversial for a long time. We assume that oxygen's oxidation number is -2 and iron has a unique oxidation number. What is the oxidation number of Fe and magnetite? So if that were true, we would solve again. So if oxygen has an oxidation number of -2, then we would write out our equation. I have 3 irons and I don't know the oxidation number, so I'm going to call that 3x. Plus there's 4 oxygen, each with an oxidation number of -2 equals the overall charge of 0. So 3x minus 8 equals 0. 3x equals 8. X equals 8, +8/3, which is a very strange oxidation number. In part C, it says that there's actually 2 different kinds of iron in magnetite that have different oxidation numbers. Suggests these oxidation numbers and their what their relative stoichiometry must be, assuming the oxygen is still -2. So what I did here is kind of think about, it even says that one common product is Fe2O3. What if we were to pull, so here's my Fe3O4, what if we were to pull Fe2O3 out of this? If we were to pull Fe2O3 out of this, what would be left? If we had if this was really a mixture of 2 different compounds, what we would have left is Fe and O, right? And if we could do an equation out just like this as well, or we can kind of uncrisscross here, figure out the charge. If oxygen is -2, then the charge and thus the oxidation number in iron here must be +3, which is a common oxidation number for iron, right? And here, what is it? If oxygen is -2, this must be +2, which is also a common oxidation number for iron. So it turns out Fe3O4 is not really Fe3O4. It's a mixture of these 2 kind of common products, oxidation products for iron. One with an oxidation number of +3 and one with an oxidation number of +2. So we've got Fe3 and here we have Fe2.